Webinar on scaling your business with additive manufacturing, sponsored by HP. I'm Rachel Bassini, Senior Editor of Design World. I'd like to thank our audience for attending this talk and our presenters, Josh Almeter and Dustin Klumpkin, for being with us today. Before we begin, let's review some ON24 housekeeping items so that you can participate in today's presentation. On the ON24 console, you'll see a number of boxes that you can move and resize to suit your preference. If you have any technical difficulties during today's session, use the help box at the bottom of your screen or the Q&A box to message us directly. If you have questions for the presenters, please type them into the Q&A box. We'll answer as many questions as possible at the end of the presentation, and they can reach out to you directly with any remaining questions. You can download the slide deck for today's presentation from the resource box on your console, and you can find direct contact information for all your presenters in the Meet Your Speakers box. Feel free to share information from today's webinar on social media with the hashtag DWWebinar. Now I'm happy to introduce our presenters. Josh Almeter is a manufacturing project engineer and 3D lab manager for ECMMS Foxconn at HP's America's Product Completion Center. Josh has worked in additive manufacturing since 2017 with HP's multi-jet fusion platform. His portfolio includes hundreds of designs and thousands of parts printed in use at the HP facility. He's responsible for design, modeling, machine operation and maintenance, post-processing and quality assurance, and department growth. His work environment focuses on practicing Six Sigma, lean, and continual improvement. Dustin Klumpkin is a lead application engineer at HP. After shutting down a bootstrap startup due to the Great Recession of 2008, Dustin has since been active around the world, advancing the undeniable impact of additive manufacturing. He's been fortunate enough to work side by side with some of the most progressive companies that desire to make the world a better place. In the past few years, he has led investigations evaluating the performance of printed orthotic and prosthetic devices versus traditional approaches, discovered massive 3D printed robotic grippers and how they can be designed and utilized, and he's worked with research institutions to cover new applications in lighting. More importantly, he holds the record for printing the world's largest mustache. It seems there's no limit to how this technology will impact the future, and Dustin is very excited about this prospect. Josh, Dustin, we're so grateful to have you here today. I'll turn the microphone over to you so we can get started.
Great. Thank you so much, Rachel, for that excellent introduction. And yes, welcome everyone to our webinar, Scaling Your Business with Additive Manufacturing. As Rachel mentioned, yes, I have been pretty busy these last 10 years in 3D printing. Here's a couple of snippets of some of that. And that mustache that Rachel was talking about is in the lower left, printed with FDM technology. And then on top of that, you know, lots of investigations into robotics, orthotic and prosthetic devices, which I'll be at the AOPA show next week. If you happen to be heading out there to Indianapolis, I'd love to talk with you. And many, many other things. So maybe that gives you a little bit more context about some of the things that I've been working on. Now, before we get into the actual content that we'll be going through today, I'd like to find out a little bit more about you. And we're going to advance to a poll here. And we'd just like to really find out if you'll be going to PAC Expo in Las Vegas. So we'll give you guys a couple of seconds to answer yes or no. We would love to talk to you if you happen to be going to that event. I know a couple of us will be there as well, so it'd be really good to hear from you. What I'll also say is once you hit yes or no, just make sure to hit submit once you've actually submitted your response or selected your response. Let's just give about another 10 or 15 seconds here. Looks like we're at about 50% just about of people. So we'll give you another 10 seconds or so. All right. Well, in the interest of time, we'll keep moving forward. I'm going to go ahead and close it up and advance to the next one. So it looks like A resounding no, at least of the people who are voting, will not be at Pack Expo. Well, that's all right. So I'll at least give you a little bit of a preview of some of the things that we will have and be talking about at the event. For those of you who didn't vote, if you happen to be going to Pack Expo, you'll be able to find us in our booth at SL-6470. Don't worry if you don't write this down. We'll be showing this again a little bit later in the show, but tell your friends, tell your family. We'd love to see you, have some conversations with you out there, and look forward to seeing some of you there. All right. Now, let's go ahead and get into what we're going to be talking about today. I'm first going to kick it off here. We started this event, or this series of webinars, a couple of years ago. And if you haven't attended the previous webinars, that's all right. You'll be able to get a lot of value from this event. But I think it's important to provide some context of how this kind of all came about. So as Rachel mentioned in the intro, we at HP hire Foxconn to help us out with some of our processes at HP. And one of those processes happens to be just taking an inkjet cartridge and putting it into a box, amongst many other things. And back around 2018 timeframe, I happened to get introduced to Josh Almonder, who we'll be speaking to later today. And that is this gentleman here on the left. He's our process engineer. And he started with one of our HP Multi-Jet Fusion 4200 machines in the fall of 2017. So he's been working with it for a number of years at this point. And when he first started, he was tapped to be that first in-house expert of HP's Multi-Jet Fusion printing process. And since he was the main person there, he had to go around talking to people about the technology and kind of pushing and educating how and where you can use this technology. And after a couple of years, now there are people that are coming to him. So he's not actively having to go out and necessarily do as much education, but they're coming to him with projects and ideas. So the reason I bring this up is we have a couple of different webinars, as I mentioned, that we've done with him. The first one we did was in 2020, and this one I like to call Adopt. So it was early on with Josh and using Multi-Jet Fusion, and so what we did is we went through what applications he used Multi-Jet Fusion for to begin with. And this is when he was really starting to get an understanding of how and where it can be used, why it's interesting, and where he can get value. And so we go through a lot of those different applications. If you haven't watched it, I'd certainly encourage you to take a look at it. We go through quite a few different applications. It's pretty impressive what he came up with just in a couple of years. Then a year later, we decided to do a check-in with him just to see, hey, what's going on? What's new? What's changing? And really what I noticed with Josh is he started to expand the scope and types of applications that he was going after. One of the things that we talked about is his ability to respond to COVID and come up with PPE for himself and his colleagues, which I think is pretty cool because it allows this one tool to be able to be adaptable with the times. And we also explore a little bit how he started to utilizing design principles for Multi-Jet Fusion and how using those was giving him extra benefits. Now today, we're going to go one step beyond that, and we're going to be looking at how he's really scaling with the technology. So it's really kind of going beyond. So we'll first do a status check to look to see how he did in 2022. Then we'll also look at a couple of strategic enablers of his success and how he was able to scale. And I'll get into some of those details of what he feels has really helped him to be successful and what I kind of see as well. And then lastly, we'll review how he's actually influenced how business is done internal to his organization and across different organizations. For those of you who are a little bit more advanced additive manufacturing users, I think you'll find this interesting. Maybe this is something that you're already doing or maybe not. What I will say, though, is if you come up with questions as we're going through this, feel free to throw them in the chat. We're really lucky to have Josh here today, so I'd like to get through as many questions as we possibly can, just to hear it straight from the horse's mouth. And as I mentioned, we'll do some Q&A. So first, let's go ahead and start and look at how he did last year. So this is pretty relevant information. And so when I was asking Josh how he did last year, what I was really curious about is what most people are usually curious about is, how much did you save? How much did you print? But the harder things that I think are sometimes hard to come across, because most people don't document this like Josh does, is where are you using the technology? How are you using the technology? And how has it shifted over time? So luckily enough, Josh is pretty organized, and he was able to produce these charts for us, which if you're brand new into additive manufacturing, this could be useful just so you can see how things will change over time, especially if you're working on the manufacturing line. And so what we see here on the left in 2018, you can see a lot of the applications that he was using it for. And I'll just back up and say that, he uses this technology primarily on assembly lines or from packaging standpoint, just in case you don't happen to know. But what he was mainly using it for, you can see 38% of his applications were conveyor parts on the conveyor line. Additionally, you can see, another 32% for automation, and then about 20% for jigs and fixtures. For me, that's no surprise. Jigs and fixtures is a really winning application when it comes to 3D printing or additive manufacturing. Now, what I find really interesting is in 2022, you can see now a huge portion of the pie, 27%, is on maintenance requests. And you can see in 2018, there was nothing. So I think that's a really interesting shift. I'm certainly going to ask Josh about this later on, because I'd like to hear his perspective on how and why he thinks that this changed. But I think that's kind of an interesting observation of how things have changed over the last couple of years. Now, additionally, I asked Josh, hey, how did you do financially or printing? And this is what he provided. He said, internally, he estimates they saved about $100,000, and he also gained about $40,000 in external sales, which I find pretty impressive. Overall, printed about 7,000 parts last year. And, if I looked at the math and did it right, I could see that, since 2017, of all the savings that he's earned to date, about a third of them were last year. So to me, that really signifies that he's really starting to get an understanding of this technology, how and where to use it, and get external business, which is pretty cool. So just to kind of level set with people, if you're jumping into this technology, it is a different manufacturing process. It's a different mindset shift, and it takes a while to kind of wrap your head around that to really start getting some of those savings and knowing how and where it makes sense. Great. All right, so what helped him to win this big? I had a couple of conversations with Josh to try to figure out what his mindset was and what were the biggest impacts for him. And to me, it boiled down to three big things. Number one is exposure. Two is process improvement. And three, his adoption of the technology across departments. So what do I mean by that? And what does Josh mean by that? So what Josh said is he said, by learning how other people are using 3D printing or additive manufacturing in other areas, it doesn't have to be manufacturing. It could be, art. It could be aerospace. It gave him new ideas of how to approach problems that he was facing. So one example that I have up here, this is a story we call the HP duct. And when we were building our 3D printers, there were a number of parts that just didn't make sense to injection mold to begin with. And we wound up finding that, hey, we could 3D print these parts, these ducts, and save actually quite a bit of money and time with producing these parts. And not only that, we could run it through an optimization software. We happen to use one of Siemens optimization softwares to even get a better airflow and get a better part performance overall. And so what Josh said is by learning about these applications, it helps him to be better at utilizing the technology. I'll also say that, if you're not familiar, on our website, you can just Google search HP 3D printing. One of the first hits will be our site. But on there, we have a drop down called solutions, and then you can look at industries. And on those industries, you can look up a lot of different use cases and videos and webinars about how and where people are using this. So if you're brand new into 3D printing and trying to get an understanding of how and where to use it, regardless of the industry, this could be a really good place to get started and to understand what people are doing with it. Now, the second point that I believe helped Josh get a lot of value from multi-jet fusion printing is he was going beyond just printing parts or duplicating parts, and instead really taking on engineering projects. So what do I mean by that? One example that I think is not really well talked about a whole lot within HP, but within HP we have these Reinventor Awards. And so one came out a couple of years ago, you can see. And with that, as many of you know, we sell quite a few laptops. And very frequently we're coming out with new models. And as such, if there's a problem with some of those computers, sometimes it can be cost prohibitive to completely redesign the computer and relaunch the computer. Well, we sold a lot of computers to different school districts. And if you're familiar, many times those laptops go into these laptop carts that charge the computers. And what some of these school districts were finding is that sometimes the charging cable wasn't fully inserting into the laptop, or it was damaging it so that it wasn't charging correctly. So the product manager at the time said, well, it's really hard for us to make a change because we're coming out with a new version here really soon. Is there anything we can do? So they talked with one of our HP printing labs. I'll give a shout out to our people out in Colorado. And they said, well, let's leverage our printing technology, see if we can solve it. So they came up with a couple of iterations, and what they settled on was this part here. And what this part is it snaps to the laptop and allows the power cord to insert into the computer very precisely so that it doesn't damage the port. And as you know, with children, sometimes they can be kind of hard on things. So this just helps to make it a little bit smoother, less chance of a failure. So they sent that out, they tested it, seemed to work pretty well. They gave it to a couple different school districts to test. They found that it worked really well. And so then they decided to go to production, mass production in particular, with this particular component. And so by being able to do that, they went through it. It was in the matter of weeks or maybe even months that they came up with a solution. And with it, we estimate we printed over 190,000 parts. And as a result, we think we avoided over $11 million in cost avoidance or cost issues. So to me, just to bring it back to Josh, this is what Josh is doing. He's not looking now at, hey, where can we use 3D printing? It's more saying, okay, what problems do we have in the organization and how could we solve it maybe a little bit differently and creatively? Great. And then lastly, one of the enablers I think of Josh's success is educating and encouraging other departments to use this technology as a natural way to solve some of their problems. And so some of the previous webinars, you've probably seen that he's using it in interesting applications. It could be on the manufacturing line. It could be for tooling organization. It could be go, no-go check gauges, amongst many other things. And the more applications you see where you can use it, the more familiar and confident you become with it, and then more naturally people are going to use it. So to me, those are some really big enablers of his success. Now, naturally, a lot of people will say, well, how big are these wins? What do they actually look like? So if we look at a couple of them, if I take one application from the first webinar of Josh's, one of the designs that he had was this guide that goes on the manufacturing line. And, he printed about 250 of these parts. I know he's probably still using these today or something similar, but he's estimating about a 98% savings compared to what he was previously doing, which I think is a pretty good return. If we look at his second webinar, one of those pieces is this paddle pusher. He came up with a couple of different designs because he has a couple of different pieces of equipment that need slight variations, but you can see, about $10,000 of savings with one design and about $6,000 in another design. And that's, two different designs. And not only that, he was able to design in a natural break part so that when it fails, he doesn't have to rip the whole machine apart just to replace one component. He can just hot swap something out, which I think is a pretty cool approach. Another application, which we haven't yet got to, that we'll focus on here is he's now starting to use this as spacers on his manufacturing line or in transport chains. And so you can see that, some of these volumes aren't really that high, but, that's where multi-jet fusion can do pretty well. It can do well up into the thousands of parts, but it can also do well in some of these smaller runs of a couple hundred parts. Not only that, some of these parts are pretty small, so I would imagine he could probably do 50, 100, maybe 200 of these parts in just a single build. So it doesn't take too long to get those printed. And then additionally, here's another application of just, you can think of 5S principles or organization principles, or even for some packaging principles, at some other savings that he's got. And then beyond that, some of the savings that you really get from additive manufacturing, especially if you're not familiar with this, is in things that are hard to quantify. I know I've mentioned this on a couple of the other presentations, but things that just make your life easier. If it's organizing some tooling, or if it's more safely mounting a big tape dispenser gun, or being able to help put up signage for safety, for example. It's hard to quantify what the value is or what the dollar value is, but it certainly makes things safer, easier, faster, more organized. And that's really where a lot of additive manufacturing value can come from. Great. So the question, though, that many times people ask is, well, how did he really pull it off? So to me, when Josh first told me about this, I thought this was kind of interesting that he's influenced the entire business workflow within his organization. And so what Josh said, he said, previously when I first started, someone would say, hey, I need parts. Maybe you need a replacement part. So they would go to purchasing and say, hey, purchasing, could you order this part? It broke on me. And they'd say, okay, purchasing would say, where's the cheapest one? Where can we go? Where can we get it the fastest? They'd place the order. And then they'd have to wait 4 to 6 weeks to have it made or shipped or something like that. And then sometimes they might have to hope that that design or that part worked for their application. If it didn't, they'd have to go through that process again, which, that's another 4 to 6 weeks. So now what Josh has been able to influence, which I think is kind of interesting, is a slightly different workflow. So now if someone needs a part, they will bring it to purchasing a lot of times, or they might go to Josh directly and they say, hey, Josh, I need this design or I need this part. Josh will either design the part himself or work with them to come up with a design. Then he will print it. He'll give it back to the person who needs it so that they can run a test, find out, did it pass? Did it fail? And then if it passes, they will submit an internal order and then assign a part number for that so that if they need that again in the future, it's just an easy order and they have it tied directly to a specific design. Or if it doesn't pass, they can iterate on that design and go through that circle of iterate, print, test, iterate, print, test until you get it incrementally just the way you want it. And I don't know this for sure, but I would imagine that process is a little bit faster than 4 to 6 weeks. I would imagine he probably gets through a couple of iterations in that time. So I'm really curious what Josh will say about that and how much that's influenced the whole business segment of what he has. So just to summarize a couple of things that I hit on before we get into some questions, and I have some questions for Josh as well. Some of the biggest benefits of this technology, you can see it's creating renewable value. So just last year, Josh saves, about $100,000 plus $40,000 of sales. So it's really kind of turning a cost center into a profit center. Additionally, what helped him to win really big is getting that exposure and learning about other applications, even if it isn't dealing with manufacturing. It gives him a different design focus and idea of how to solve problems creatively. Also, he's not trying to necessarily push additive manufacturing anymore, but he's really trying to solve problems within the organization, just like that computer situation that I highlighted. And then lastly, he's really helping other departments to adopt the technology by getting confident and comfortable with it, so that it can lead to better utilization and potentially better design and production processes. Great. So now we're going to get into some questions with Josh. I'll also mention, feel free to throw some questions into the chat. Before we get to your questions, though, I have a couple of questions that I'd like to discuss with Josh, so that give you guys some time to type up some questions. Again, I'll just throw out there, here's the booth that we'll be at PAC Expo, so tell your friends. So Josh, I have a couple of questions for you. And the first one that I have for you is, since you're kind of a long-time user of Multi-Jet Fusion now, it's first off, you guys are kind of hard to find, and secondly, not always willing to share some of the things that you've been working on. But I'm curious, what your mindset has been like from shifting from when you first got the printer until now, and more specifically, maybe you can talk a little bit about this chart that I brought up earlier on, where early on, many of the parts were from conveyor parts and from automation, and now a lot of them are coming from maintenance requests. So I'm curious if you're able to kind of talk about how your mindset has shifted and what maybe surprised you or shocked you or anything like that.
Yeah. First, Dustin, thank you. It's good to see you. Thank you for hosting. Thank you for having me. Yeah, before and after AM, during, so I'll say where we started was my company reached out to the local university, Virginia Commonwealth University, because my company wanted to get into additive manufacturing and did not know about it. So they talked to a university. The university recommended an FDM printer. We got a MakerBot, and I started with that. How that happened was they wanted someone to learn 3D printing because no one knew the technology, and I was the youngest engineer, so I got volunteered to do it. And from there, I started to learn, and then also understand the limitations of FDM, and also began to understand that additive manufacturing is a very, very broad field. So we found that the FDM printer could not fulfill a lot of our projects and needs. So my company went back to me. They said, hey, could you make a recommendation on what kind of technology? Say if we need to make 100 widgets that are this large or this large, how long? We need to make them in less than 2 weeks was basically the requirement. And so I did a bunch of research, SLS, resin printers, 3D printing farms with FDM printers. I put them all together, all the costs, all the disadvantages, all the advantages, and all the speeds. And then I made a presentation, and my company went with Multi-Jet Fusion technology because it had some of the highest capacity and highest quality parts for that price range. So that's like kind of how we got the 3D printer. Now, kind of actually to get into your question, is like how it started versus how it's going. Yeah, it was a steep learning curve. I had to learn a lot myself, even just coming from FDM. The technologies are totally different. The way you design parts, the way that you set up builds, the way you process parts, everything is completely different. So that took a lot of learning. And then also the learning on everyone else in the company. I'm making a lot of parts for our facility, for our manufacturing lines, but I'm not necessarily the person dealing with those parts after I make them and send them out the door. It's a maintenance technician that is replacing them, that is stocking them, that is working with them, right? And in the very beginning, most maintenance technicians didn't even believe that a 3D printed part could do anything. And I think that is partly because most people's exposure is only to FDM parts that are mostly for prototyping and visuals and things. But now that we have a printer that can make final end use parts that are strong, even once we still had that printer, it took a while to get everybody on board. because they still had those lingering doubts and impressions of 3D printing. And again, to highlight on what Dustin saying about these numbers and everything, yeah, so in the very beginning, I had no maintenance people my first year come to me and ask me to make 3D parts. Which, yeah, it sounds crazy because of the people who are working with the parts most. It's the department consuming the most parts. In the beginning, I was busy because I had a lot of engineering projects lined up. I already had a lot of needs identified, but we still ended up using our technology for things that we didn't even expect since the beginning. So that was definitely a change there. And but over the years, we did find that we found. I'm sorry, let me start over. Over the years, yeah, so maintenance started coming to me. At first, they did not, but eventually, people got exposed to the technology, and they said, wow, this is really great. This actually makes my job a lot easier because maintenance technicians have a job. They have a lot of work to do. They don't necessarily have the time to go make some custom parts, to tinker around, to try stuff out. You know, they're worried about the business, keeping the machines running. So people come to me, use me as a resource now for their ideas to help them. I'm like the internal product development person, essentially. And this is something that totally did not exist before we had a 3D printing department. That's for sure.
So, you know, that kind of triggers a memory in my head from a previous webinar where you said something like many of the people who are running certain pieces of equipment, they're just trying to keep that equipment online and running and doing whatever it takes. And so it sounded to me, and correct me if I'm wrong, but it sounded to me like in the past, these experts didn't have much ability to really keep a machine going if something broke or if it wasn't quite right, because they didn't have an ability to make new parts or safety equipment or anything like that. And if I'm understanding you correctly, now it sounds like they can go to you to say, hey, I have this idea of how to make this process better or faster or safer, and you're able to help make that a reality. Would you say that's correct?
Yeah, I would say there's like two parts to what you said. One was it can be difficult to get parts. I mean, we have backup contingency for everything. So if one line is down, another one is able to step in its place. But maybe it does take 4 to 6 weeks to get that custom part. So that's not permissible in a manufacturing environment, at least in today's age. That's why we have double contingency. And if you talk about inventory, digital and physical, reduction is cost savings. And to the second part, yes, incremental improvement. I think all companies, especially those practicing lean, are practicing continuous improvement. And the way this technology works, like you had said, is you don't design a part, make an order, and then that is the entire lifetime of that part. You don't make any changes to it until all those parts are broken. You have to order more. Now you can make incremental improvement to your parts and your processes. Before, it was just too cost inhibitive. It was too time inhibitive. Now this iterative process, like we could maybe go through several iterations of a design in a single week, you know, and then produce the full run of those parts the following week. So that has been a huge culture shift in our company, just because, I mean, talking about things that are hard to quantify is really the speed, the savings and the amount of downtime, and then also all these incremental improvements.
And then, you know, on one of the first webinars we did, we looked at a part that was metal that you wound up discovering could be printed in plastic. And I'm sure that was a pretty big hurdle because people are probably used to making parts always in metal for that particular application. And so I'm curious, after you were able to prove that you could print it in a polyamide 12, for example, would you say that kind of opened people's mindset about how and where you could apply this technology?
Yeah, absolutely. Like I said, at first, all the maintenance technicians didn't believe plastic parts really had a place here. Many things are made out of stainless steel, aluminum. And that one first part example you showed of those flights, those were all aluminum flights that were all milled from a solid block. You saw how much open area was in those. Those were extremely expensive. That's why we're able to have 98% savings. You saw it's not a lot of plastic printed there. Now, the reason why it was metal in the first place is because it's a manufacturing line that we contracted a large manufacturer to build for us, 15 years ago, 10 years ago. So this line is how they designed it. They over-engineered it. And we wouldn't really have thought those parts. I didn't consider those parts to be replaceable, but had the ability to try it. So when they're coming up for a rebuild on that machine, and then they had to order thousands of parts, which was like hundreds of thousands of dollars. And so they said, hey, Josh, what parts could we 3D print out of all these? So I went through all the parts and we tested them, and we had plenty of time to do this. The amount of time it takes an order like that to go through. We had plenty of time to test all that and identify certain pieces that were previously made out of metal that we could now print out of plastic. And then you have tons of other benefits from there too. Because if you have a jam or a break, it's usually less intense. There's a lot less weight on the belt, so it increases the longevity of your chains and your drives and your motors. I mean, there's a lot of benefits that are hard to quantify.
And didn't you even mention that you helped to improve the design of that particular component and wound up working with the supplier to, help them improve their design?
There was a lot of different design improvements with those. One being that it was a multiple part assembly. So instead of having a base, a top, and 2 screws and some washers or some inserts in the plastic, now I was able just to combine those all and print it as one piece, because you didn't have the confinements of injection molding for the shape of your design. So I was able to eliminate a bunch of components. And 2, we did alter the geometry of that design. I had talked to the maintenance technicians that work on that line the most, and they said, hey, we want you to reinforce this area a little bit. We want you to bring this angle in a little bit. We want to change the length of this arm just a little bit. And, we normally wouldn't make a change like that. Why would we? We would just get the OEM part from the manufacturer, or we would go to a machine shop and we would give them our old part and say, hey, please, could you make me 200 of these exact duplicate? But we're able to test those improvements and find that, we're able to get a higher efficiency out of our line. And, with all manufacturing, if you're getting higher, this is like one of the only ways to make money in manufacturing is to get improvements in efficiency.
Yeah, and you were able to get some of those ideas from those other expert technicians that are running that equipment, right? So that you guys could kind of, have a hive mind approach of both you with the design and printing expertise and them with running the equipment to come up with a optimal design that either one of you probably couldn't do by yourself, I would imagine.
Yeah, it's the hybrid of working between people who are experts in their own regard. And like we were saying, these were the people at first who were shaking their heads at the 3D printing, didn't think it was going to be good use for anything. And I was having to track them down and push them into an involvement. Now, like you're saying, they come to me, hey, can you print this? Hey, could you make this little change? I mean, can you imagine you're a maintenance technician and someone's like listening to you and like trying out your ideas? Like this is, it's a different culture.
Yeah, just out of curiosity, how many times, maybe a week or a month, would you say you have people coming to you now? Because I know you said you didn't have anyone coming to you in 2018.
Every day. Every day someone comes down, finds me. They find me, right? It's not like I'm hiding or anything. But they will find me. His job, where, because I work in a bunch of different places on the floor, and it's either to follow up on something we're continuously working on, or it's because someone has a new idea. It's like approachable like that. It's not like they have to go through a bunch of levels of approvals and recommendations.
So you've really kind of helped create a whole culture shift of collaboration and coming up with new designs and processes and efficiency. Really, it kind of sounds like.
Those are your words, not mine.
So nice work. That's not easy to do. Great. I'll just mention again to everyone attending, make sure to throw your questions into the chat. I'm going to go ahead and jump to one more question before we open it up to everyone else. So one of the questions that I sometimes get or I hear from people is the designing for additive manufacturing process. So if you have any experience with printing technology versus manufacturing, you probably know that you need to design for the process, which, that's one thing. But you can also take it to the next level and really start to try to design for the inherent advantages of that printing process. If it's FDM or PolyJet or SLA, multi-jet fusion, they all have their unique strengths, and you can design for those particular strengths. And so with that, it can take some extra work to understand how to design for that process, or to take those extra steps to cut down on the extra weight of the part or something like that, or to add in a honeycomb. And so a question I have for you, Josh, is it can be a lot of work to design for a particular process. And I'm curious what you think about if you feel the juice is really worth the squeeze. And just as an example, I know you provided to us this robotic gripper part, and we can see kind of the boxy one on the right. On the picture at the left was the original design, and the one on the left was the DFAM design. And so I'm curious what that experience has been like, and how it shifted from when you started compared to today.
Yeah. So there are restrictions with designing for multi-jet fusion, but I will say it is one of the least restrictive design manufacturing processes I've ever been involved with. Coming from a more traditional background of injection molding, those all have to be designed a certain way. Undercuts and things, a bunch of features you can get away with multi-jet fusion. So when you're speaking from a design standpoint for multi-jet fusion, it's way easier because you don't have those constraints. And then you mentioned FDM. FDM is based on the amount of plastic you're using. The amount of moves equals the amount of time it takes it to make, also the strength. Also with overhangs, again, you have limitations. Maybe you need support materials. Multi-jet fusion does not need support materials. The unfused powder acts as support around the part. Now you do have to have powder removal, as with this vacuum block. When that is printed, there's actually powder inside of those hoses. It is not fused, but that part needed to be designed in a way that I could easily remove those powder to make that part functional. But as far as design consideration, this is like a new generation of designer. Like, you don't have to have this old legacy of knowledge for CNC, what different tool heads can do, what different kinds of cuts. For injection molding, what things are allowable, what will be able to be ejected from the mold. That is not a consideration at all. But the vacuum block, for this example, yeah. So at first it started by me copying a version that we had. We had a new product, we needed new spacing, we needed a new vacuum block. So the first thing I did, I took it and I lightweighted it. That is that version you see on the right there. It used to be a big block of Delrin that was machined down into a smaller block with these features. And you drill out the plumbing for it, and that's how we started. That was fine. Now, years later, we had to change that part again, and I said, okay, at this point, I think I'm going to redesign this part, because I had learned a lot over those years. I had been exposed to a bunch of different designers through HP, through going to different expos, through design studies. HP actually does a really good job about putting out white papers and design examples. So I looked at those and I was like, man, everyone's parts are looking so cool, and my parts are not as looking like they're behind the times. So this part I started and really kept minimal design in mind, right? The part only had a couple requirements. It needed the whole suction cups at a certain spacing and a certain sequence. With multi-jet fusion, you can actually thread into the plastic. It's strong enough for that, so that was no problem. And then I decided, instead of using hoses for the plumbing, I would use printed hoses, and that way I could get away with a lot of the bulk of the part. I made the actual structure and support of the part those hoses. That way, everything else is not needed anymore. It's really come down to a skeleton piece. And then also I needed this platform on the bottom, so when you pick up product, there's something flat to press against. This I still lightweighted, even even further. So I mean, these parts are, I don't know the exact weights, but the lightweight one is a lot lighter than my old lightweight one. And there's tons of benefits from that. Our cobots, they can move faster. They can take a higher payload. There's less wear and tear on the joints. I mean, these sort of robotics have started to be used everywhere, and that's how I was able to get that kind of exposure and be able to look at different ways to design and take cues from other people. So it's gone from a place from, at first, yeah, we would copy parts. You had a broken part, you would just reverse engineer it. You would draw it on the computer, and that's your replacement part. And then maybe the second part, like you're saying, you're trying to change a little bit for multi-jet fusion. Oh, maybe let's remove some weight. The multi-jet fusion is a heat-based process. So you're getting multiple benefits by reducing weight. One, you're using less plastic and material and agents. Two, you're having less heat in your builds, which impacts the amount of parts and density that you can have in the builds that you make. So we gone from that, and then yes, to completely trying to take full advantage of this technology to make pretty much whatever we want.
Mm-hmm. And with the time it took you to do that redesign, what was it, a lot of extra time, or was that something that was easier for you? Because I know people have sometimes said, well, you know, it can take, you know, an extra 5 or 10 hours to do that versus the benefit. Is it really worth it? What would you say to someone that says something like that?
I mean, this all depends on the speed of your designer.
Yeah.
I think 5 years ago, it probably would have taken me all day or a couple days to make something like that. But, you know, practice, you know, most engineers today have CAD exposure. I mean, they all did 10 years ago, but I mean, especially now, everyone is knowing 3D modeling. Everyone's getting better at it. There's a lot more opportunities. Same with 3D printing. There were so many people who didn't, including myself, didn't know 3D printing even going through college, but now they have it in elementary schools. And that's the point too. They also have CAD design further and further down that chain in high schools and so forth. So this new one maybe only took me an hour or two. I would have to look back maybe. I don't know if there's a record for how long it takes, but I mean, the amount of time was a blink compared to what it would have a couple years ago. So having a good, luckily, I think most companies already have a pretty good design team, or at least somebody. If you're outsourcing parts or ordering parts or designing parts already with your company, you probably already have someone on your team that's a good designer. And again, HP has put out a lot of white pages on design for multi-jet fusion, which I have read and I have learned. So I'm able to have all those keys and thoughts in my mind when I'm designing a part from scratch. But when you're using such a simple process like that, and you're not having to consider injection molding, machining, all that, I mean, you really just building it from scratch. There's not that much work to do. Like for those, I made a suction cup, pattern it, put it all around, made a hose, patterned it, reflect, and then put the bottom. Like it really turned out to be a simple part when you remove all those extra things that aren't needed.
Great point. So in the interest of time, we're going to go ahead and jump into some of the other questions I see are coming in. So Rachel, maybe if you can identify a couple of questions that might be coming out from people.
Sure thing. And just first of all, thanks so much for this wonderful presentation. And to remind the audience here, if you have any other questions, keep putting them in the Q&A. We'll get through as many as we can. And whatever we aren't able to complete today, the presenters will reach out to you directly. So let's see. One of the first ones here is, when replacing metal parts with HP parts, how do you have any rules of thumb to make sure it's strong enough?
I don't know if we're going to do-si-do on the questions. For
ahead,
us,
Josh.
it is primarily everything is a safety issue at our plant. We would never replace something that seemed risky if it had a safety implication. If it's a metal part that is completely enclosed and we can test it and there's not a safety risk, then that's good to go. Now, of course, there's other risks like to the other parts on your machine also to be considered, but primarily we look at if we're replacing a metal part with a plastic part, is it going to pose a safety risk to any of our team members? I would say that's the first rule of thumb for that one.
Great.
All right. Another question, has HP ever used its own printers for pilot production of newly designed inkjet cartridges? If so, have they been as leak-free as injected molded ones? Or if not, if they're not used for such prototypes, why not?
Yeah, I'll take that one. And Josh, maybe you have a different angle, but really good question. Interesting question. I haven't gotten that one before. From my understanding, I don't believe so. But what sometimes happens when you're setting up a manufacturing line is you need to train all the different operators who are operating the equipment to verify that they understand how the equipment works, how the packaging comes together, et cetera. And so what I do know that we occasionally do is we will 3D print dummy parts in the design that we're actually fabricating and run it through the entire manufacturing workflow. And in that way, we can get everyone trained, verify that the equipment is doing what it needs to do for that particular device, if it's putting in a screw or cutting something. And sometimes that can help get everyone up to speed so that by the time the product actually arrives or the raw goods arrive from wherever they're coming from, you can get up and going right away. So I do know that they do stuff like that. And then also sometimes for dummy parts where if you're assembling things together, maybe there's an open pocket and you don't want parts to fall down, you can 3D print some kind of dummy part that kind of fits in that slot to help you with the assembly a little bit better. And then Josh, I don't know if you have any other experience or insight on that for that question. That's a really good question.
I think that is exactly right. I've had some of your HB team members have part requests from the West Coast, and I've made exactly that. I've made different jigs and fixtures for manufacturing, different trays that would be made out of molded pulp. With 3D printing them first to see, is it going to work through the manufacturing process? Is it going to fit? Is it going to seal? What is it actually going to look like in hand? And I've also made dummy prints. Dummy pins, dummy ink cartridges. So, and I believe, I wasn't sure what they're using them for, but I imagine it's for those same purposes, for testing how they're going to look, what's the proportions on it. That's a big benefit of having a physical copy of something in your hand.
Okay.
Yeah.
Another question about the strength of parts. So how strong are the printed threads in the 3D part? What thread count was tested and finally used?
Okay. So I will say there's limitations. It's also the type of threads that you use in your parts. One, size is a big impact. Second is printed versus cut. So you can actually print 3D threads, and if you have a light duty application, that is totally sufficient. If it is a stronger application, then you can print the drill hole size, and then you could actually tap the part with a normal tap that you would have in your machine shop, and now you're getting an even stronger level of thread. The third level is actually just using a metal insert in your parts, and a lot of people are doing this because they have very rigid requirements for the strength of threads. But I found those inserts that people use, either a push insert where you heat it up and you put it directly into the part, or a threaded insert where you tap the part and then thread that insert in. Those have been extremely strong. The other comment I would say that if you get down to low size threads, those really is where you start to have strength problems, because if you have a plastic printed thread, especially if you're 3D printing the thread, anything like M3 and smaller is not going to be strong enough. It's just too fine of detail for plastic to hold enough rigidity. But it's also the amount of depth of those threads too, right? It's a factor of the diameter and thickness of those threads, but also the depth of engagement you have. So there's a couple different factors. I would say, yes, you can definitely do it. I do it a lot, but you would have difficulty on small threads and maybe heavy applications.
Okay, great.
Great answer.
We might have time for one or two more. Let's try, how long does it take you to redesign traditionally made parts for multi-jet fusion?
So I guess that's keeping in, you're suggesting that the part is being changed, I assume, to be redesigned. Because, there's a bunch of different cases. It is a very common case that someone brings me half a part, a broken part, and says, hey, this is the only one we have. It's broken. Can you redesign it? And I redesign it exactly as it was made the first time, because that's how it fits into the machine. That's the maximum amount of strength maybe you can get by using the most amount of material. But a lot of the time they come back to me, especially if it's something like a Delrin block that's been machined into a guide or into a certain shape or anything, any sort of, or even a metal part that's been machined. Anytime something's been CNC'd, right, the least amount of cuts, the better, because it saves you time on the CNC machine. But what that results in is you get a very large and heavy part. So redesigning that part for multi-jet fusion, like with the vacuum block example, could just be as simple as lightweighting. So you take that part, you design it, you have a copy of it, and then you just go and you look at areas where you can remove the amount of material. And that can either be shelling, that could be like doing a honeycomb pattern. And if you have certain softwares, this can go incredibly fast. I mean, with SolidWorks, you can do a shell with a one-click operation. If people are using, I don't have materialized Magics, but if you have Magics, this is an extremely powerful tool for multi-jet fusion workers, because you can take a part, you can take a large part, you can, I think in a one-click operation, you can honeycomb it. I think in a second click, you can break it into multiple smaller parts. And then with a third click, you can actually add tongues and grooves and assembly characteristics of your broken down part, even add in tolerances for the type of glue you're going to use to reassemble it. I mean, there's a lot of technology that can make you do things really quickly and easily for additive manufacturing design.
Awesome, thank you. I think that's all the time we have for questions today, but please continue entering them in and our presenters can reach out to you directly. But first, before you go, we actually have one more poll question for you. So would you like to receive a part sample? Yes or no, and then please remember to select submit after your answer. We'll give you a couple seconds to fill that out.
And while you fit that out, I know we talked about press fit inserts. On the next slide, we're going to have, there's a link to our design handbook. In the design handbook, we have a section on inserts. So if you want to learn more about that, I'd certainly encourage you to check that out. There's quite a lot of really good information on that in there.
We'll give just another 10 seconds for everybody to enter their response. Alrighty, so here are all the resources from today's session that you can download from your console. Again, any more questions, keep entering them in, or if you want to be notified or given more information, you can enter your contact information and our presenters can reach out to you. Thank you again for attending this Design World webinar, and thank you Josh, Dustin, and HP for helping bring this great information to our audience. This presentation will be mailed to everyone later today, and it'll also be available at designworldonline.com. Thank you again, and make it a great day.